Hi, welcome to our channel of IGNOU Audiobooks, School of Agriculture, SOA. Certificate in Organic Farming, COF. BAPI 001 Organic Production System. Block-1 Farm Management. Unit-2 Seed and Planting. 2.0 Objectives. After studying this unit, you will be in a position to define seed and an organic seed. Explain dormancy and methods of breaking dormancy. Underline importance of seeds and planting materials in farming, and assess the seed rate and sowing methods of different crops, fruits, vegetables, cotton, sugarcane, etc. 2.1 Introduction. We know, seed is the most important input in crop cultivation. Good quality. Seeds planting materials have high germination and vigor that form the basis for obtaining high yields. Good quality seeds planting materials should be reasonably pure and free from insect damage and diseases. Only healthy seeds of suitable variety should be selected. There should not be any mixture of seeds of other varieties or weeds. The seed should be purchased from a reliable source, and it should be organically certified. Before sowing, the seed lot must be tested for its germination percentage, while sowing the seed's quantity should be adjusted accordingly. Time of sowing is one of the important aspects in obtaining good germination of the seeds. It has also a marked influence on the yield. Farmers have been producing seeds and planting materials over the years to suit their ecological, nutritional, tastiness, medicinal, fodder, fuel and other demands. These are called farmers' varieties or land races. Farmers' varieties are also referred to as indigenous seeds, native seeds, organic seeds, if farm is certified, heritage seeds, jwari, nate, desi, etc. Farmers' varieties are sustainable. Crops differ in their seed structure, germination pattern and planting geometry. According to the crop plants, we should adopt the geometry. 2.2 Seed structure and its germination. 2.2.1 What is a seed? A seed is a small embryonic plant enclosed in a covering called seed coat with some stored food to give the seedling a faster start. It is the product of the ripened ovule which occurs after fertilization and also has some growth within the mother plant. Seeds are used as propagating materials for crops such as cereals, legumes and trees. An organic seed is the seed from plants grown organically and certified, or could be seeds from farmers' varieties or desi varieties, subject to certification by an accredited certifying agency. 2.2.2 Seed structure. A seed contains an embryo from which a new plant emerges under ideal conditions. Seeds also contain a storage of energy which is wrapped in the seed coat or testa. Seed protects and nourishes the embryo. The embryo has one cotyledon or seed leaf in monocotyledons, two cotyledons in almost all dicotyledons. When it germinates, the radicle and plumule emerge out. The radicle is the embryonic root. The plumule is the embryonic shoot. The embryonic stem above the point of attachment of the cotyledons is called the epicotyl. The embryonic stem below the hypocotyl. The seed structure with all the given below. Look at the screen. Fig. 2.1 A. Monocote seed structure. B. Dicot seed structure. 2.2.3 Seed germination. It is a process of emerging out the radicle and plumule from the seed coat of a seed under favorable conditions. First, the seed absorbs water which causes it to swell and activate different enzymes in the endosperm. This process is termed as imbibition. However, the nature of the seed coat determines how rapidly water can penetrate and subsequently initiate the metabolic process of germination. The nature of germination differs with the types of seed. For example, monocote seed has different germination pattern in comparison to that of dicot seeds. Let us examine both the germination patterns separately. Monocote seed germination. In monocote seeds, the radicle and cotyledon are covered by a coleorhiza and coleoptile, respectively. The coleorhiza is the first part to come out of the seed, followed by the radicle. The coleoptile is then pushed up through the ground until it reaches the surface. Then it stops elongation and then the first leaf emerges out from the seed and begins growing in upward direction. Fig. 2.2 Monocote seed germination. Look at the screen. Dicot seed germination. In this case of seed germination, the first plant part that emerges out the embryonic root, termed as radicle or primary root. This allows the seedling to become anchored in the ground and start absorbing water. At the same time, the hypocotyls begin to elongate. While elongating, it pulls up the cotyledons and enclosed shoot above the soil surface. Once the cotyledons are above the soil surface, the hypocotyl moves upward up and the cotyledons begin to unfold. After unfolding, the shoot growth continues and subsequently new leaves are differentiated. Two types of seed germination has been found in case of dicot seeds. Let us study them. A. Epigeous. In epigeous germination, the hypocotyl elongates and forms a hook, pulling the cotyledons and shoot above the soil. Once it reaches the surface, it pulls up the cotyledons and shoot tip of the growing seedlings into the air. Examples: beans and tamarind. Look at the screen. Fig. 2.3 A dicot seed germination, epigeous. Example: beans. 1. Radicle. 2. Hypocotyl. 3. Foliage leaves. 4. Cotyledon. 5. Epicotyl. 6. Hypocotyl. B. Hypogeous. In hypogeous germination, the epicotyl elongates and forms the hook. The cotyledons stay underground and get decomposed later on. Example: peas. Look at the screen. Fig. 2.3 B dicot seed germination, hypogeous. Example: peas. 1. Radicle. 2. Hypocotyl. 3. Hypocotyl. 4. Epicotyl. 5. Cotyledon. 6. Foliage leaves. R. I 2.2.4 Requirements for seed germination. The seed germination depends on many factors. The external factors include water, oxygen, temperature, light, and the right soil conditions. Different sets of variables operate for the successful germination of seeds of different varieties. Now, let us study the impact of different factors on the seed germination. Water. Germination requires moist conditions. Mature seeds are extremely dry and need to take up significant amounts of water before their metabolism is resumed. The pressure caused by imbibing water aids in cracking the seed coat. When seeds are formed, most plants store large amounts of food in the form of starch, proteins, or oils for the activity of embryo inside the seed. When the seed imbibes water, hydrolytic enzymes, such as amylases, are activated. Breaking down of the stored food resources take place and gives energy to the seedling to grow. Oxygen. Most seeds respond best when water levels are enough to moisten the seeds and oxygen is readily available. Once the seed coat is softened and cracked, the germinating seedling requires oxygen for its metabolism. If the soil is waterlogged, then there will be dearth of oxygen supply and prevent the seed from germination as it prevents aerobic respiration, which is the main source for the seedling's energy until it starts photosynthesizes. Temperature and light. Temperature is an important factor for seed germination. Often, seeds have a set of temperature range for germination and will not germinate above or below a certain temperature. There are minimum, Maximum and optimum ranges of temperature. Collectively, these are called cardinal temperature, 2.3 seed dormancy and methods of breaking dormancy, 2.3.1 seed dormancy. Seed dormancy refers to the failure of a viable seed to germinate under favorable environmental conditions. In some dormant seeds, morphological changes take place before the start of germination. Under natural conditions, necessary changes take place gradually under varying combinations of aeration, moisture, temperature, and light. In general, there are two types of seed dormancy: seed coat dormancy and internal dormancy. Seeds with seed coat dormancy usually have a hard seed coat. Such seed coats are impermeable to oxygen and/or water. Occasionally, the dormancy is caused by an inhibiting chemical in the epidermis or adjacent interior membranes. Under natural conditions, these seeds remain on or in the ground without germinating until they have been weathered sufficiently. The weathering allows penetration of water, exchange of gases, or neutralization of inhibiting chemicals. Seed coat dormancy is common in legumes. If the seed of such plants are harvested at green, partial immature, and sown before they dry out, germination is reduced. However, once the seed is dried out, the dormancy is present, which must be counteracted to obtain prompt germination. Methods of breaking seed coat dormancy include scarification, hot water, dry heat, mulch, water, cold, and warm stratification. In another case, there are certain chemicals present in the endosperm or testa of seed which does not allow the hydrolytic enzymes to function. Until they are inactivated or leached out from the seeds, the seed does not germinate. 2.3.2 Methods of breaking the seed dormancy. Scarification. Scarification is a mechanical technique used in some legumes. It dampers the seed coat and reduces its impermeability. It is done by rubbing seeds between two pieces of sandpaper or using a file, a pin, or a knife to rupture the seed coat. Seed may also be mixed with coarse sand and shaken vigorously in a jar. Care must be taken to avoid injury to the seed embryo. Hot water, for small to medium-sized seeds or when we have a large quantity of seeds, the hot water treatment is more practical than scarification. For this treatment, seeds should be dropped into about 6 times their volume of preheated water, 82 to 93 degrees Celsius. The seed should be left to cool and soaked in the water for 12 to 24 hours, after which they are ready for sowing. The container used for this treatment should not be made of aluminum as it may be toxic to the seeds. With hot water treatments, the seeds should be sown promptly and not stored again. Mulch. The mulch treatment hastens the microbial breakdown or softening of the seed coats. It is a slow method but often occurs in the nature. For this treatment, fill a 6 to 8 inch deep container half with seedbed medium. Then the seeds should be covered with a mulch of wood shavings. Rice straw is used for soil bed nursery. And 1 inch thick layer of old composted shavings is best, but if not available, a 3 inch layer of fresh shavings may be used. If fresh shavings are to be used, they should be soaked a few hours in a bucket of water first and mixed with a compost, starter of microbial inoculants. Neither the seeds nor the medium should be treated with a fungicide. Water. For the occasional species whose seed coats contain a readily water-soluble, germination-inhibiting chemical, this substance can be removed by soaking the seeds in tap water or by leaching the seeds in slowly running tap water for various lengths of time just prior to soaking. The length of time depends on the species. With the water bath, changing the water every 12 to 24 hours will hasten this leaching process. Softened water should not be used for this treatment. Cold stratification or pre-chilling? Cold stratification or pre-chilling is useful for seeds with internal dormancy. The embryo of many seeds fails to germinate because oxygen does not diffuse through the seed coat. At cold temperatures, more oxygen is soluble in water, so the oxygen requirements of the embryo is met readily. Warm stratification, the exposure of seeds to moist, warm conditions at room temperature or above is called warm stratification. Sometimes this treatment is necessary for seeds with internal dormancy to facilitate after ripening of the embryos. 2.4 Seeds and sowing planting. 2.4.1 Cereals and millets. 2.4.1.1 Rice. Seed equipment. Seed treatment is an essential component in the organic farming. The treatment protects against insect pest attacks and helps establishment of healthy seedlings. We should use the following methods and inputs for the seed treatment in different crops. By cow dung. Soak the seeds in a mixture of 1 kg each of cow dung, cow urine and water. 1 liter and 100 g of cow's ghee for 10 minutes. The seeds are shade-dried for 6-10 hours. By neem seed kernel extract. About 25 kg shade-dried neem seeds kernel is crushed and the coarse powder is tied in a cotton cloth and immersed in 50 liters of water overnight. Next morning, the cloth containing the soaked seeds is squeezed to separate the extract. Again, the remaining neem seeds are dipped in 50 liters of water and extracted completely. This extract is coated over the paddy seeds. The seeds should be dried in shade for 6 hours before sowing. By biofertilizers. Azospirillum, Azotobacter and phosphobacteria are the common biofertilizers used for paddy. For seed treatment, 200 g of azospirillum is suspended in 1 liter of water. This mixture is sprinkled over 25 kg of seed spread on a clean surface and mixed thoroughly to coat uniformly. If Azotobacter is available, 750 g of Azotobacter is mixed in 1 liter of water and the slurry is uniformly coated over the seeds needed for 1 hectare. Phosphobacteria at the rate of 1.25 kg dissolved in 5 liters of water may also be used. This paste is uniformly coated over the seeds. The treated seeds should be dried in shade and sown within 6 hours of treatment. Detailed description of the biofertilizers is presented in next block of this course. Seeding dip. The seedlings before transplanting may also be treated with biofertilizers. Azospirillum at the rate of 150 g is mixed in 20 liters of water and roots of the seedlings are dipped in the mixture for 10 minutes. 2.5 kg of azospirillum will be sufficient to treat the seedlings needed for 1 hectare. If Azotobacter is available, 600 g Azotobacter inoculants is mixed in 20 liters of water and then the seedlings are dipped in the slurry for 5 minutes. Methods of sowing. Broadcasting or direct seeding. The seeds are broadcasted after plowing the field to proper tilth. The seeds may be mixed with the soil with the help of local plow or disc harrow. About 100 kg seed per hectare is sufficient. Sowing behind the plow or drilling. In this method, the seed is sown with seed drill or behind the plow with the help of funnel in the rows. The row-to-row distance should be 20 centimeters. About 60 kg seed is sufficient for 1 hectare. Transplanting. In areas where there is assured water supply, a nursery may be raised and the seedlings are transplanted at the proper age. System of rice intensification, SRI, technique. System of rice intensification is gaining popularity now. This technique was originated in Madagascar. Under SRI system, 6 to 8 kg rice seed is sufficient for planting 1 hectare area. The nursery size should be kept at 90 to 120 m2 LXW. The seedbed is prepared on raised bed in the main field itself. Compost or organic manure at the rate of 1 kg per square meter is mixed into the soil in the seedbed during final plowing. As an alternative, seedlings can also be raised on a plastic sheet. By spreading compost and topsoil mixed in equal proportion to 1 to 2 cm thickness. The seeds are soaked in water for 12 hours and kept in wet gunny bags for another 24 hours to initiate germination. For protecting the seedlings against diseases, Pseudomonas fluorescens, 4 liter, should be mixed with water used. For soaking the seeds. The germinating seeds are broadcasted into the seedbed at the rate of 200 g per 3 square meters, and then the seeds are covered with a fine layer of soil. The seedbed is irrigated daily in the evening with light sprinkle. After 8 to 12 days, vigorous and healthy seedlings are ready for transplanting. While transplanting, only one seedling should be used per hill. The seedlings should be lifted gently from the seedbed and should be transplanted immediately. The root damage should be minimized. The seedlings should not be beaten or washed in water to remove the soil as practiced traditionally. Seedlings should be placed in 1 to 2 centimeters deep into the muddy soil. A spacing of 25 by 25 centimeters should be adopted. If seeded, it may be increased to 30 by 30 centimeters or to 40 by 40 centimeters. 2.4.1.2 Wheat. The optimum sowing time of wheat varies widely over the growing areas. It depends upon I. Type of variety, 2. Weather conditions, 3. Soil temperature, 4. Irrigation facilities, and land preparation. In general, the maximum productivity potential of promising wheat varieties under irrigated conditions is attained by sowing them between Loth and Tush November in all the climatic zones other than the peninsular zone. Rain-fed wheat is generally sown during the second fortnight of October to early November. Under specific circumstances, wheat is sown in the month of December too. In late sown wheat, only short duration varieties should be used. Seed rate and spacing. Seed rate varies with the variety used. It also depends upon seed size, germination percentage, tillering ability, time of sowing, moisture content in the soil, and method of sowing. Usually, a seed rate of 100 kg per hectare is sufficient for normal sowing. For varieties with bold grains like Sonalika under late sown conditions, seed rate should be increased to 125 kg per hectare. In case wheat is to be sown by dibbler, a seed rate of 25 to 30 kg per hectare is sufficient. For normal sown crop, a spacing of 20 to 22.5 centimeters between two rows is recommended. When sowing is delayed, a closer spacing of 15 to 18 centimeters should be adopted. Methods of sowing. Broadcasting. The seeds are broadcasted and then mixed in the soil using harrows. Generally, uniform seed distribution cannot be achieved, leading to irregular plant stand and poor germination. When the broadcasted seeds are not covered properly, they are picked up by birds, resulting in wastage of seeds. Hence, this method is generally discouraged. Behind local plow, the seeds are dibbled by hand into the furrows that are opened with the plow. This is called kera, hand, method. When it is dropped through a pora or nai or hazara, a special attachment with local plow, it is called pora method. The seeds are dropped at a depth of 5 to 6 centimeters. The germination is satisfactory under this method of sowing. Drilling. Before sowing the seeds by drilling, the seedbed should be thoroughly prepared. It should be well leveled, free from clods and weeds. The seeds are sown by seed drilling at uniform depth. It results in uniform germination and regular stand. Dippling. When there is limited seed availability, this method is used for sowing. Dibblers have a wooden or iron frame with pegs. The frame is pressed in the field and lifted, and then 1 or 2 seeds are dropped by hand in each of the hole. It is a time-consuming process. Zero tillage technique. This method is useful under rice wheat cropping system. After harvesting of rice crop, field requires at least 6 to 8 tillage operations. Plowing and harrowing to make field ready for sowing of wheat. A zero-till seed drill machine is used for direct sowing of wheat in rice field, without field preparation. This helps in advancing of the sowing of wheat. Under zero tillage, there should be proper moisture in the field at the time of sowing. The rice crop should be harvested close to the ground. The field should be free from weeds. Sowing depth of about 5 to 6 centimeters should be maintained. Light plank may be used behind the machine. 2.4.1.3 Match. The match seed should be planted at a distance of 20 to 25 centimeters between plant 2. Plant in a row, and rows should have a distance of 60 centimeters. The seeds are sown at a depth of 3 to 5 centimeters. 10 to 20% more seeds than the desired plant population would be normally required to compensate for various field losses. A seed rate of around 20 kilograms per hectare should be used. Planting on the side of a ridge is adopted in high rainfall areas. Planting is done in narrow furrows in low rainfall areas. Under normal conditions, the planting is done in flat bed. In areas that face heavy storms during rainy season, planting on flat bed followed by earthing up after 40 to 50 days is recommended. Date of planting differs from place to place. However, the following guidelines have to be observed in choosing the date in the case of Kharif match. In areas with irrigation facilities, planting is taken up to weeks before the onset of monsoon. In rain-fed situations, the sowing of match is done with the onset of rains. Sowing should be done through match planter or seed drill or manually. Behind the country plow in furrows. 2.4.1.4 Sorghum, Jowar. A seed rate of 12 to 15 kg seed per hectare is sufficient to ensure a good stand of crop. The seeds are sown in rows 45 centimeters apart with a plant-to-plant distance of 12 centimeters and at a depth of 3 to 4 centimeters. Jowar is sown either by broadcasting or in rows behind the plow. In northern India, jowar is sown only during Kharif season. In irrigated areas, first week of July has been found suitable for sowing of improved varieties. Under unirrigated conditions, sowing should be done preferably within a week after the onset of first monsoon showers. Rabi sowing is done mainly in Maharashtra, Karnataka, and Andhra Pradesh. Rabi sowing should be done after the second fortnight of September to the middle of October. Summer crop of jowar is sown in the month of January and February in irrigated areas of Tamil Nadu, Andhra Pradesh and some parts of Karnataka. 2.4.1.5 Bajra, pearl millet. About 5 kilograms seed of pearl millet is sufficient for 1 hectare area. A spacing of 45 centimeters between rows and 10-12 centimeters between plants is followed. Seeds are sown at a depth of 2 to 3 centimeters. Bajra is generally sown behind plow or by broadcast method. As these methods are not efficient, use of bajra seed drill is recommended. It ensures better seed germination and uniform plant population. Bajra is a predominantly rain-fed crop. However, it can be raised round the year in areas of assured water supply. In most of the states, bajra is sown during June to July. If timely sowing of bajra cannot be done, transplanting may be adopted. Transplanted crop matures earlier, produces more tillers and earheads. About 2 kg of seed is sown in 200 square meter nursery mixed with area organic manure. To get seedlings for 1 hectare, The seeds are sown in flat beds, 1.20 meter x 7.50 meter, in row of 10 centimeters apart and at 2.5 centimeters depth. The seedling are uprooted and transplanted after 3 weeks. While uprooting the seedlings, keep the nursery wet to avoid root injury. Transplant 1 seedling per hill in rows, keeping 50 centimeters space between rows and 10 centimeters space between plants in a row. 2.4.1 6. Barley. For sowing of barley in rain-fed and saline areas, the seeds are soaked in water overnight. In such areas, sowing should be done in the 3rd and 4th week of October. In irrigated areas, sowing should be done during 1st and 2nd week of November. In irrigated areas, for normal sowing 75 kilograms seed of barley per hectare is sufficient. While in late sown conditions, seed rate should be increased to 100 kg. Under rain-fed condition, 75 to 100 kilograms, and for saline soils, 100 kilograms of seeds per hectare is required. For irrigated barley crop, a spacing of 22.5 centimeters between 2 rows is recommended. Sowing should be done at a depth of 4 to 5 centimeters. For rain-fed crop, a spacing of 23 to 25 centimeters between rows is recommended. Sowing should be done at a depth of 6 to 8 centimeters depending upon soil moisture. Seeds are dropped with the help of pora or nai attached to a local plow or with the help of seed drill. In irrigated areas, seeds are sown by kera method. In kera method, the seeds are dropped by hand into the furrow. 2.4.1.7 Finger millet, Manduya. The irrigated crop of finger millet is sown in more than one season in Karnataka, Tamil Nadu and Andhra Pradesh. The rain-fed early crop is sown in April or early May. Kharif season main crop is sown during May or June. If the rains are not received in time, the sowing is shifted further up to the end of August. However, sowing should be done early in rain-fed condition to avoid moisture stress at critical stage, i.e. flowering. In areas where irrigation facilities are inadequate, the sowing should be done soon after the onset of monsoon. In the higher hills of North India, the optimum time of sowing for Manduya is the first fortnight of June. The irrigated crop in Rabi season in Karnataka, Tamil Nadu and Andhra Pradesh is sown during September and October. Normally, 8 to 10 kilograms seed is required for 1 hectare area under line sowing. When crop is raised by transplanting, 4 kilograms seed is sufficient for raising nursery. It is beneficial to sow Manduya 3 to 4 centimeters deep. Line-to-line distance of 20 to 25 centimeters and plant-to-plant distance of 8 to 10 centimeters are considered ideal. In areas with adequate moisture, Manduya can be raised by transplanting. Seed should be sown in well-prepared nursery beds during the month of May to June. 3 to 4 weeks old seedlings should be transplanted in the main field. Before uprooting the seedlings, the nursery should be irrigated. Field should be well prepared. Before transplanting, 2 seedlings per hill at a distance of 25 by 8 centimeters or 20 times 10 cm may be transplanted at a depth of 2 to 3 centimeters. The beds should be irrigated on the 3rd day after transplantation. In the absence of timely rains, transplanted fields should be irrigated regularly till the seedlings are well established. 2.4.1 8 Proso millet, China, and barnyard millet, Savan. As a kharif crop, proso millet should be sown in the first fortnight of July with the onset of monsoon and as a summer crop during the middle of April. During summer, it would be desirable to sow China after harvesting of the Rabi crop. Proso millet can be sown by broadcasting or by drilling seeds in furrows 3 to 4 centimeters deep. Row-to-row distance should be kept 25 centimeters and plant-to-plant 10 centimeters. Line sowing ensures better germination, cut down seed requirement and facilitates intercultural operations compared to broadcasting. Depending upon the method of sowing, about 12 kilograms of seed is required for sowing of 1 hectare. Barnyard millet can be sown during first fortnight of July with the onset of monsoon. The seeds are broadcasted or drilled in furrows at a depth of 3 to 4 centimeters and a row spacing of 25 centimeters. The seed rate of 8 to 10 kilograms is sufficient for 1 hectare area. Transplanting is also done in some places in Maharashtra. In flood affected areas, it is sown with the first shower, broadcast method and harvested before the occurrence of flood. 2.4.1.9 Kodo and cocoon. Sowing time for kodo is between 15th June and 15th July in northern India. In south, it is mostly grown as rain-fed crop from September to December. Kodo millet is sown at a depth of 3 to 4 centimeters deep, with line spacing of 40 to 45 centimeters and plant distance of 8 to 10 centimeters. The seed rate required is 10 to 15 kilograms per hectare. An early crop of cocoon is sown in May, main crop in June to July, and the late crop in August. In areas of assured water supply, summer crop is sown in February to March. Optimum time of sowing of cocoon in Tamil Nadu is August to September for rain-fed crop and June to July for irrigated one. In Madhya Pradesh, it is grown as a rain-fed crop. The crop is generally sown in rows at 25 to 30 centimeters distance. Seeds should be sown in furrows 2 to 3 centimeters deep. 8 to 10 kg seed is sufficient for sowing of 1 hectare. 2.4.2 pulses and all seeds. 2.4.2.1 Chickpea. Second fortnight of October is the optimum time for sowing of the chickpea in most of the chickpea growing areas of northern India. For peninsular India, first fortnight of October is the best time. Delay beyond this period results in conspicuous reduction in the yield. Under humid subtropical condition of Tarai, first fortnight of November is the most suitable period. The crop may be sown by seed drill or behind local plough at a row spacing of 30 to 45 centimeters. A seed rate of 75 to 100 kilograms per hectare is sufficient. The seed should be placed at a depth of 8 to 10 centimeters. 2.4.2.2 Lentil. Middle of October is the most suitable time for sowing of the lentil. Sowing should be done in rows made at 30 centimeters apart. This could be done either by using a seed drill or by seeding behind desi, country, plough. The optimum seed rate for normal sown crop is 30 to 40 kilograms per hectare. Seed rate should be increased to 50 to 60 kilograms per hectare in case of late sowing. Row spacing should also be reduced to 20 to 25 centimeters in case of late sown crop. Lentil seeds should be sown at a depth of 3 to 4 centimeters. 2.4.2.3 Field pea. Second fortnight of October is the optimum time for sowing of field peas in North India. Seeds are sown at the rate of 60 to 80 kilograms per hectare with a spacing of 30 centimeters between rows. The optimum time for sowing of garden peas, vegetable purpose, is first fortnight of November in northern India. The early maturing varieties are given closer spacing and higher seed rate, while the late maturing varieties are given wider spacing and lower seed rate. In case of early maturing dwarf varieties, crop should be sown in rows 20 centimeters apart and 100 to 125 kilograms seed is required per hectare. In late maturing and taller varieties, a row spacing of about 30 centimeters is optimum. The seed rate should be reduced to 75 to 80 kilograms per hectare. Sowing of pea should be done when the daily maximum temperature is below 30 degrees Celsius and the daily minimum temperature comes down to 20 degrees Celsius. 2.4.2.4 Pigeon pea. Arhar. Pigeon pea should be sown during the first fortnight of June. Under rain-fed conditions, sowing could be done with the onset of monsoon during the later part of June or early July. Seed should be sown behind the plough or with the help of seed drill at a spacing of 60 to 75 centimeters between rows and 15 to 20 centimeters between plants. A seed rate of 12 to 15 kilograms per hectare is sufficient. In mixed cropping, seed rate is adjusted according to the proportion of arhar and companion crops to be grown. In the intercropping, seed rate remains same as for the pure crop. 2.4.2.5 green gram, mung, and black gram, urd. In Kharif season, sowing of green gram is done with the onset of monsoon. In central and southern India, Madhya Pradesh, Andhra Pradesh, Tamil Nadu and Orissa, mung is sown during October to November as a rabi crop. In Uttar Pradesh, Punjab, Haryana, Delhi, Bihar and West Bengal, mung is grown an irrigated crop during summer season. Sowing is done from the middle of March to middle of April. During Kharif season, 12 to 15 kilograms of seeds per hectare should be sown in rows 45 centimeters apart, while during Rabi and summer season 20 kilograms of seeds per hectare should be sown in rows 30 centimeters apart. Sowing can also be done behind the local plough or with the help of seed drill. It is desirable to treat the seeds with rhizobium culture. During Kharif Sayaso, sowing of black gram is done with the onset of monsoon. A 12 to 15 kilograms of seed is sufficient for 1 hectare. A wider spacing is adopted, wherein the furrows are opened at a distance of 45 centimeters. Sowing could be done from the 3rd week of February to 1st week of April, when black gram is raised as a summer crop. About 20 to 25 kilograms seed is required for 1 hectare. The furrows are opened at a distance of 20 to 25 centimeters. Seed drill could be used for this purpose. Seed should be inoculated with rhizobium culture before sowing. 2.4.2.6 Cowpea and soybean. Suitable time for sowing of cowpea crop is March to April. The sowing for Kharif cowpea starts from middle of June and extends up to the end of July. In hills, this crop is sown in April to May. For green manuring, the crop should be sown from middle of June to 1st week of July. For grain or vegetable purposes, 20 to 25 kilograms seed is required for sowing of 1 hectare pure crop. For mixed cropping, the seed rate is reduced proportionately. For fodder or green manure purpose, the seed rate should be 35 to 45 kilograms per hectare. The row spacing of 35 to 45 centimeters and plant-to-plant distance of 8 to 10 centimeters may be maintained for Kharif planting. The row spacing in summer planting should be 25 to 30 centimeters as the plants do not grow much. The crop can be sown either with drill or behind a local plough. IR. Northern India, soybean can be sown from 3rd week of June to 1st fortnight of July. The sowing should be done with a row spacing of 45 to 60 centimeters and plant-to-plant spacing of 4 to 5 centimeters, with the help of seed drill or behind the plough. The depth of sowing should not be more than 3 to 4 centimeters. About 70 to 80 kilograms seed is required for 1 hectare. If raised as a late sown crop, the seed rate should be 100 to 120 kilograms per hectare. Soybean seeds should be inoculated with suitable strain of Brady Rhizobium japonicum for biological fixation of atmospheric nitrogen at the rate of 0.5 kilograms per 70 kilograms seed. 2.4.2.7 Groundnut. There are 2 types of groundnut viz, bunch type and spreading type. For bunch types, the row-to-row space is 30 to 40 centimeters and for spreading type, it is 45 to 60 centimeters. Plant-to-plant distance should be kept at 15 centimeters for bunch type and 20 centimeters for spreading type. The seed rate per hectare for bunch type is 80 to 100 kg and for spreading type, it is 60 to 80 kilograms. Sowing is done at a depth of 5 centimeters. Using the country plow, dibbler or seed planter. 2.4.2.8 Rapeseed and mustard. Usually it is recommended that the seed rate of 5 to 6 kilograms is sufficient for 1 hectare area when grown as pure crop and 1.5 to 2 kilograms seed per hectare for a mixed crop. Sowing is done either behind the plow or through seed drill. The spacing between plants is 10 to 15 centimeters and the spacing between rows varies from 30 centimeters to 45 centimeters. 2.4.2.9 Sunflower. The seed rate for sunflower is 8 to 10 kilograms per hectare. The seeds are sown at a depth of 3 to 4 centimeters. The spacing recommended is 60 centimeters between rows and 20 centimeters between plants. 2.4.3 Cotton and sugarcane. 2.4.3.1 Cotton. There are two types of cotton, American and Desi. The seed rate varies with the types of cotton being cultivated. A seed rate of 15 to 25 kilograms per hectare for American cotton and 10 to 18 kilograms per hectare for Desi cotton is recommended. We should maintain a spacing of 60 centimeters between two rows and 45 centimeters between plants in a row for American cotton and a spacing of 60 centimeters between rows and 30 centimeters between plants for Desi cotton. The seed should be placed at a depth of 4 to 5 centimeters and covered with thin layer of soil. Line sowing with seed drill is recommended. 2.4.3.2 Sugarcane. The planting material for the sugarcane is called set. The top 1/3 to half portion of a cane which has buds of high viability is the best for preparing the sets. The seed cane should be 10 to 12 months old. About 35,000 to 40,000 sets are needed to plant 1 hectare area. The sets of 30 to 45 centimeters length with 3 buds are normally used. Sugarcane is planted at a distance of 75 to 90 centimeters. Either in shallow furrows, flat planting, opened by local plow, or deep furrows, opened by ridger. In case of trench planting, trenches are formed with help of a ridger or by manual labor. 2.4.4 Fruits and vegetables. Mango saplings are planted in pits of 0.9 x 0.9 by 0.9 meters with a spacing of 7 to 10 m for dwarf hybrids. A closer spacing of 2.5 by 2.5 meters or 5 by 5 meters is recommended. For citrus group of trees, pits of having size of 75 times 75 x 75 centimeters are dug out with a spacing of 5 by 5 meters for lime, 6 by 6 meters for lemon, grapefruit and mandarins, and 7 by 7 meters for sweet oranges. Seedlings raised vegetatively or through seeds are used for planting. Banana is propagated by suckers. Well-developed suckers having narrow sword-shaped leaf blades, sword suckers, should be selected and used for planting. Pits of 45 centimeters depth are prepared and filled with topsoil mixed with 10 kilograms of farmyard manure before planting of the suckers. Grapes are another category of plant propagated vegetatively. Rooted stem. Cuttings of 20 to 30 centimeters length with 3 to 4 buds are used for propagation. Pits of IX1 by 1 meter size are dug at a spacing of 3 by 5 meters for muscat variety, 5 by 5 meters for Thompson seedless and 6 by 6 meters for Anabishai. Papaya is propagated by raising saplings in the nursery. The matured saplings are planted in the pit size of 45 times 45 x 45 centimeters with a spacing of 1.8 m apart. Either way are used to accommodate 3,000 papaya plants per hectare. In each pit, 2 to 3 seedlings per hole at 30 centimeters apart are planted. When they reach the flowering phase, 1 male tree for every 15 to 20 female trees is retained. The other male trees are removed. Direct sown crops like okra, lablab, French bean, cluster beans, and cowpea can be sown on one side of the ridge at a spacing of 30 centimeters. Amaranthus should be sown after mixing 1 part of seeds with 20 parts of fine sand by broadcasting in the plots. Small onion, mint and coriander can be planted or sown along the bunds of plots and edges of the path. Seeds of transplanted crops like tomato, brinjal, chili and big onion can be sown in nursery beds 1 month in advance by forming shallow lines in the soil. After sowing, seeds should be covered with topsoil. Seedlings are removed from the nursery after 30 days in the case of tomato and after 40 to 45 days in the case of brinjal, chili and onion. Tomato, brinjal and chili seedlings are transplanted along one side of the ridge prepared at a spacing of 30 to 45 centimeters and the seedlings of onion are planted on both sides of the ridges at a spacing of 10 centimeters. Trailing crops should be planted on the soil surface. These crops include ash, gourd, pumpkin and bottle gourd. Their seeds should be sown in the pits at the rate of 2 to 3 seeds per pit. The cucumber should be sown at a seed rate of 2 kilograms per hectare with 5 seeds per pit. The seed of watermelon 3 to 4 kilograms per hectare. After germination, the seedlings are thinned to 3 per pit. For deerkins, 2 seeds per hole are dibbled at a depth of 5 cm and the holes are placed at a spacing of 45 centimeters apart. For planting of the cabbage in 1 hectare area, a nursery bed of 60 to 80 square meters should be prepared. The seed rate is 300 to 500 g per hectare and sown at a depth of 1.5 to 2 centimeters with 5 to 7 centimeters spacing. Seedlings of 4 to 6 weeks old are planted at a distance of 60 by 30 centimeters or 45 by 45 centimeters for early crop, 60 by 45 centimeters for mid season crop and 60 by 60 centimeters for late crop. If direct sown, cabbage seeds are sown in the hills with a spacing of 60 by 30 centimeters at the rate of 2 seeds per hill. In the case of cauliflower, seed requirement for early crop is 500 to 800 g per hectare and for the mid and late crops, it is 300 to 400 g. Seeds are sown on nursery beds and are then covered with grass mulch. After 3 to 4 weeks, seedlings are planted in the main field at a spacing of 60 by 30 centimeters or 60 by 45 centimeters. For carrot sowing 5 to 6 kilograms seed is sufficient for 1 hectare area. The seeds are small in size, so it is recommended that the seeds should be mixed with sand and then sown on the ridges or on flat land by opening furrows with a spacing of 30 to 40 centimeters. Spacing of 6. Radish is sown directly in the field at a depth of 1.25 cm and 8 cm between plants and 30 to 40 cm between rows is followed. The seed rate recommended per hectare is 8 to 10 kg for tropical type and 10-12 kg for temperate types. Potato is grown from tubers. One should always prefer cut tubers with an L cast. 1 eye is used. The cut pieces should be cured at 10-15 OC and 85 to 95% relative humidity for 4 to 6 days. The quantity of seed tuber required for planting 1 hectare land is 1500 to 2000 kilograms. The tubers can be planted at a spacing of 60 by 15 centimeters either in ridges and furrows or in flat beds. Tapioca is an important crop used for various purposes in South India. It is basically a rhizome crop. It is propagated by sets. Sets are prepared from the middle portion of fully matured plants. Each set should have 5 to 6 buds. The basal ends of the sets can be dipped in a solution of azospirillum culture, 30 g in 1 liter of water, for 20 minutes and planted with correct polarity.
Garlic is an important member of spice crops. We use it daily in our culinary preparations. It is vegetatively propagated by cloves. a quantity of 500 to 600 kg of cloves per hectare is required for planting at a spacing of 15 by 10 centimeters. Perennial vegetables like curry leaf moringa, sesbania, checkemones, etc. are planted in pits of size 45 centimeters x 45 centimeters x 45 centimeters, dug at a spacing of 2 m pit to pit. 2.5 Summary. We have studied in this unit the characteristics of good quality seeds planting. Materials. They are required for obtaining higher yields. We know farmers prefer their own produced seeds that suit the ecological, nutritional, taste, medicinal, fodder, fuel, and other needs. The meaning of seed, organic seed, structure of seed and germination are presented in this unit. The concept of dormancy and the methods of breaking the dormancy are also discussed. The methods of sowing, planting, seed rate, spacing, depth of sowing or planting, and implements used in sowing for cereals, millets, pulses, oilseeds, cotton, sugarcane, vegetables, and fruits are explained. For organic farming, seeds of own farm or from a certified organic farm should be used. Thank you.